Alright, number 7 looks like we're going to do the whole process. It says use traditional methods, or using traditional methods takes 9.7 hours to receive a basic license. So that's going to be our mean. 9.7 hours. We have a new method, a computer method proposed, and the researcher used 24 students, so sample size is 24, and it's 24. They observed they had a mean of 9.4, so the sample mean x bar is 9.4. Standard deviation, so this is the sample standard deviation, S is 1.4, and a level of significance of 0.5, and it says that will be used to determine if they perform differently. Assume the distribution is normal. So when it says differently, we don't know if it's more or less, could be greater than or less than. We just want to know if it performs differently. Now, the significant level of 5% tells us that 5% is in both tails. So if we divided that evenly, that would be 2.5%. Or 0.025. So we're going to be using 0.025. We could either use the 2-tail or the 1-tail for 5%, or 2 tails for 0.025 to find if these perform differently. Now our null and alternative will be listed as follows. Since the question says we only want to know if it performs differently, then we're going to say the mean given is not equal to 9.7. That means it's different. Something other could be greater or less than, or either the mean of this new computer test is equal to 9.7, and they're the same. So even though we got 9.4, it looks like it's a little bit less. Just because that was a little bit less this time, it could be, higher the next time and average out, or it might be such a small difference that it doesn't make a big change. So I'm going to find those critical values first. So I'm going to go to the T-chart. Our degrees of freedom are going to be 23. It's n minus 1, so it's going to give us 23. I'm going to make this full screen so I can see it. So as I was showing you, that level of significance is 5%, and 1 tail, let me see, this is 10%, this is 5%. So 5% is going to be the area in the 2 tails. The 0.025% is if I looked on one side. Okay, so I'm looking up to 5%. That's what I was kind of showing. And we're going to look for 23 degrees of freedom. So right here, 0.2069. 0.2069. So we got, sorry, 2.069, and this is negative 2.069. Double check just because I was saying that with the point out of the wrong place. Let's verify. 23, 2.069. Yes, okay. 2.069. Alright, so we got two-sided. Here we are. Now we just need to compute the test statistic. If it is bigger than the positive or smaller than this negative number, then we reject this in favor of this. And if it is in between these two, that means it could be equal to. It might not necessarily be different. Okay, so we're going to compute our test statistic. So T, which I've been saying Z, is the test statistic. Z equals T equals. That's going to be that sample mean 9.4 minus the true mean 9.7 divided by the sample standard deviation 1.4 divided by the square root of the sample size, so it'll be square root of 24. Okay. So we're going to compute this and get a number. So I'm just going to do it piece by piece. 9.4 minus 9.7. Alright, now we're going to divide. And then in parentheses, I'm going to put the denominator, which will be 1.4 divided by the square root. So second square root of 24. And then close. So we get negative 1.049 or negative 1.05. Negative 1.05. Okay, so 0's in the middle, and the further to the left I go, I get further here. This number is negative 1.05. That would fall here somewhere. So let's say that this number is negative 1.05. It does not fall in this rejection region, so we fail to reject, which means there is not enough evidence to say that these two tests are different. So our conclusion this time, we would fail to reject the null. Looks like it might be sleep, so let's refresh. Let's get back in. Should be the same question. This is 10.3. Continue. So yes, 9.4, 9.7, 24. Okay, same question. Again, what we got, our test value was negative 1.05, which did not go further enough to the left. So we would fail to reject the null.